Now let me show you graphically. Let me show you graphically the logistic regression. Look, it is XY plane. It is a two-dimensional model. I'm showing you the two-dimensional logistic regression classifier model. For example, these are two data classes. When you apply the logistic regression, you will have this form of decision boundary. It is a decision boundary. So we call it a decision boundary, and this is the data set. It is a threshold value with a 0.5. This is my 0 and this is my 1. So we can say that it is class 1, this is my class 2. It is a logistic regression classifier model. Look, we have created a two-dimensional logistic regression classifier model where I have two data sets, class 1 and class 2. This is my decision boundary in the S shape. These are the data sets. This is the threshold value, where the range of the logistic regression as we studied in the definition is from 0 up to positive 1. From 0 up to positive 1. It is not a zero-centered function. It is from 0 up to 1 with a threshold value of 0.5. So look what the logistic regression does. Its performance is to classify the data, into its own specific class. For example, if you have the data points here and here, here, all the way, what the logistic regression does, when you apply the logistic regression model, it will bring all the respective data of class 1 into here, up to here, and all the respective data of the class 2 here. So there will be a decision boundary in the S shape. Don't forget it. The decision boundary of the logistic regression of the sigmoid function is in S shape. There will be S-shaped boundary where all the data classes are above the decision boundary here. Class 1 data sets are above the decision boundary. It actually blocks their own respective data sets into their own classes with a threshold value. Look, threshold is the middle value of 0 and 1. The middle value of 0 and 1 is 0.4. This is a threshold value. Above the threshold value we have class 1, and below the threshold value we have class 2. But look, in the class 1, there won't be any data set below the decision boundary. Don't forget it. Everything will be above the decision boundary. Similarly, in class 2, there won't be any data set below the decision boundary. Everything will be above the decision boundary into this space. So this is the practical model, a two-dimensional model of logistic regression classifier. I repeat it, its range is from 0 to 1 with a threshold value 0.5. For example, you have data sets here, here, and here, here, and here. When you apply the logistic regression model, it will classify, it will bring all the respective data into their own classes and will settle them above the decision boundary. There will be a decision boundary in S shape. Don't forget it. It will be in S shape with a threshold value. So this is my class 1 and this will be my class 2. There won't be any data set below the decision boundary. Everything will be above the decision boundary. It blocks all the respective data sets of class 1 above the decision boundary. Similarly, in class 2, all the data points will be above the decision boundary. There won't be any data point below the decision boundary. It will block all the points from class 2 above the decision boundary. Threshold value is the middle value. It is the middle value of 0 and 1, which is 0.5. Above the threshold value is my 1 class. Below the threshold value is my second class.